Okay, we're live now. Happy New Year. I'll be pasting the link here in the chat for the agenda as soon as my beach ball disappears. There it is. I hope you all had restful holidays and that you've hit the ground running. There's Andre. I know him
Hi guys.
from the sound of his microphone. Hi, Andre. All right. Let me give a quick update. I'm going to let
Steven? You still there?
Uh-oh.
Doesn't look like Steven's there. Let's see. We give him a minute.
Yeah.
It probably would be better to wait for our updates until he's back. But there you go.
He's out.
It might be worthwhile actually pausing the live on air. Does anybody else have access to that?
To what?
The live on air, because this is until Stephen gets back.
No.
Yeah,
All right. How much time do you have, Porrig?
Sorry?
How much time do you have?
Not well, maybe until 20, 30 minutes.
Okay. I think he wanted us to go first.
Yeah.
Yeah, I mean, I can very quickly just say that I haven't actually got a very much OpenWorm specific updates. Plenty of work on open source brain and NeuroML tools, which will eventually all feed into the C. elegans model, but nothing very much specific on the C. elegans NeuroML project itself, so, unfortunately. Did you?
So, Tom.
Yeah.
Oh, did you want to go? Well,
you want to go? Okay, yeah, because I got a work meeting in less than 20 minutes now.
Okay. Well, go ahead.
Oh, there he is. He's back.
Man, that was a really unfortunate moment for everything to just crash on my machine.
Yeah.
So, at least I shared the link. Okay.
Well, you missed Porrig's update, but he didn't have much.
Okay. Well, did you get a chance to write it into the agenda anyway?
I can do.
Okay, cool. That'd be great. All right, very good. All right, let me give a quick thing then. Sorry, guys. My computer ran away with me. Okay, I just wanted to say two things. So one, so Journal Club since last time. So first of all, thanks to Ben Shi, who's been doing great work on pushing the ball forward and organizing, getting everybody ready. So the last one was on December 11th. I think it was a really great discussion. We had Eduardo Izquierdo and Randall Beer on. We talked about their work. I think it was well received. I've seen folks have continued watching it over the break, so that was a good one. In terms of the so by the way, this is really on the latest on modeling worms, and I would really recommend that paper. And if you haven't had a chance to see that Journal Club, to catch up with it, because I think it really makes it clear kind of what some of the scientific challenges are that the whole community is facing in terms of figuring out locomotion, how it's driven by cells, and that kind of thing. Okay, so the next one, which Ben just got out here last night, is coming up on the 22nd. I think opening it up may have been the thing that crashed my machine the last time, so I'm going to let other folks go to the link. But it's up on Google Plus on the event page there, and it'll be out on other social media later today when I get to it. Basically, this one is going to be with Saul Cato, and looking at the data that they just recently put out in Cell, which I think is very exciting, where they're analyzing over 160 of the worm neurons isolated individually, but en masse as an aggregate, and they have a very interesting vantage point. It's some of that whole brain recording basically, but done as analysis, and so we'll be talking about that. And I think that the implications for modeling are huge, so stay tuned for that one. I think it'll be good, coming up pretty quickly. Okay, the other thing that you guys hopefully all received also went out over social media over the break. Basically a year-long newsletter, the 2015 OpenWorm in review. It was sort of an attempt to piece together a summary of everything that kind of got done. I tried to really address as many topics as I could think of that were in 2015. I hope I didn't leave anything out in particular. I would like to build on that process of getting the word out to folks. Maybe it's something that we can all do together, so that we can all have put whatever text we want in that kind of a posting going forward. And I think as we increase the level of formality around the group as it relates to any of the OpenWorm Foundation stuff, I think that'd be useful. But bottom line on the demographics on it, we now have a pretty big list of individuals that have opted in to listen to OpenWorm content. So I believe that last time I checked, there was like 600 people that had opened the email on the newsletter to kind of get informed by that stuff, which is pretty great return rate for any email campaign. So there are folks listening. There are folks who care about what's going on, which is really great. And I think it was a nice way to just kind of close 2015 and start off with 2016. So as we go forward, I'll be soliciting, I think, more from everybody as to what we want to announce and what we want to talk about. But that is a channel that we can use going forward. So, okay, and there may be some other stuff to talk about when we get down a little bit further. But so Pora gave his update, which was great. Maybe we'll get an update from Tom, and then go around from there.
Okay. Yeah, sorry about that. I work called a meeting yesterday, so got to do that.
No problem.
Yeah. Anyway, so yeah, I've been working with Bradley, and our upcoming thing to do is is send in a chapter for a book called Multi-Agent Based Simulations Applied to Biological and Environmental Systems. and reading that. So it turns out we got to expand the chapter by like at least double it. So we're trying to scratch our heads and figure out how to do that. So what it is it's if I didn't mention it for a while, it's basically a nested neural cellular automaton, and it has some nice properties. You can use it, train it to do some tricks, like you can train it to do Turing's reaction diffusion stuff, and the game of life, and cell regeneration, and axon finding, and stuff like that. So there's a pile of tricks you can do with it, and it has some nice properties, which is because of the nested thing, which is kind of naturally maybe more plausible. And what I mean by that is far away things are fuzzier, close-up things are more precise, and you have this thing called what I call a precision gradient. And so you can basically you don't get a combinatorial explosion by making a neighborhood bigger and bigger. It grows linearly actually. So anyway, that's coming up in March, and got to get that going more readily. So that's pretty much my update.
Excellent. Very good. Sounds good. So is it? Would you say that that's like a hierarchical system?
Oh yeah, absolutely. It's hierarchies of nested neighborhoods that become less precise as they grow. So it's like there's nested contexts, for example. So
cool. So I remember.
Yeah, go ahead.
I remember seeing some of the. So is that incorporated into Morphozoic now?
Yeah, that's what it is really. That's
okay.
Yeah, a piece of is in a fundamental part of it. So
cool. So at some point I'd like to check out what like the hierarchy part of it, because I think I've seen it only at one level.
Yeah, I remember way back. Yeah, it doesn't look anything kind of like what you saw. I think way back.
Okay.
I had that hokey C. elegans picture kind of morphing,
right.
which is kind of stupid. It was just for show, but it does do some interesting tricks.
All right. So what is the are you getting to a point where you feel like the results of it that are coming out are helping to uncover some of the relationships that you guys kind of want to get at with some of the fundamental principles of development?
Well, yeah, I mean, we're the Devo worm thing. I hope I'm not, talking above my station here. Bradley will. It has to do with development. So morphogenesis is like a big ticket item. So it's an abstraction. It absolutely is. Okay, you know me. I'm a computer guy. So, but we're like looking. I mean, nature has tons of examples of morphogenetic fields which affect the development of differentiation of cells and things like that. So, is there some common thread here that you can pull out that, without enumerating a huge list of things that nature's done? That's the question. So kind of attacking that. Is there some kind of computational commonality?
Cool. Very good. All right, yeah, I just wanted to get a little bit more on that. Yep. Go ahead, Brandon.
Well, I mean, that sounds pretty good. I mean, they've been trying to figure out ways to make what Morphozoic can do more relevant to development itself, or other types of pattern formation. So, in the book chapter, there are all sorts of examples or benchmarks that we'll go through. Various things that the program can do. Some of them are just sort of general pattern formation, and some are more biological in nature. So I guess the next step then would be to kind of figure out what one next step is to figure out how relevant to biology it can be. Maybe kind of explore some of those avenues.
Yeah, that's a good point. So, pick some particular morphogenesis or differentiation biological phenomenon, and try to see how that more closely can model that. if
Yeah.
if that's possible. So sort of zoom in on something biological.
Yeah.
Now that we kind of zoomed out, and now we're kind of maybe the next thing is to kind of zoom in.
Yeah. I mean.
Cool. Okay. Well, Bradley, since you started talking anyway, do we want to just go ahead and go to you, and maybe you can speak more broadly about other aspects of the DevoWorm stuff?
Yeah. So DevoWorm, we've been doing that. We've been So we're preparing two manuscripts. One is the Morphozoic book chapter, and then the other one is this invited paper that Dick and I actually were invited to write. And I think his wife is on the paper too. And it's basically an analysis of C. elegans development, like embryogenesis, and then comparing it with Ciona intestinalis, which is a tunicate. And so this tunicate system is actually also very, they worked out the lineage tree, and they have what they call a fate map, which is where you can, look at where the cells, the cells divide deterministically, and they end up forming tissues. And so everyone knows kind of what cells contribute to what tissues, and it's very much like C. elegans, but it actually has a much larger number of cells in the organism. So, we're doing some we're working on this comparative analysis aspect. And like we're going to say something about mode of development, because this is a unique mode of development. If you compare it with like human development or mouse development, this sort of development that C. elegans has is unique, and we can learn something about how it works. So, maybe we can find some underlying principles and maybe, simulate development at a very general level.
Awesome. And question two, I know that at some point there was some conversations about maybe getting some imaging data on C. elegans embryos with the Elegant Minds group. Is that,
yeah, so, I haven't heard much about that. I mean, they were in the loop a while back, and then it kind of fell out of the loop. So I don't know if they're still working. I talked to the head of the group, and he said that there were some students who were trying to do something on it, but
okay.
Yeah.
Okay,
Yeah, that's sort of an interesting, because I don't believe they've actually applied any machine vision, right, Bradley,
Yeah.
on those videos. So that's like we could do that and see if we could actually parse out some individual cells, and essentially make a model of things from the videos. So.
Yeah, it went out in the year in review a little bit, just linked to their site again, and just kind of a refresher. I think in this year I really do want to re-engage with them. Also, I know that at some point the movement analysis group was also looking to them for some potential videos. So we probably got to get them on and start talking in a bit. Just more regular context, maybe, so everybody knows kind of what's going on with that. So something good for this year.
Yeah.
Cool. Anything else, Bradley?
I think that's it for right now. I'll keep you updated.
Awesome. Good stuff. Excellent. All right. Let's keep on going. Andre, maybe to you. I'm hoping that you can share some exciting visual progress, some stuff that I think I've seen in the last couple weeks or whatnot. So what's your update for the group?
Well, yes, it's possible to show something, but it will take some time. Well, first of all, we have finally simulated more complex movement than before. So the at first stage, the worm crawls and moves forward. Then it reverses and continues movement backward. As it happens when the worm is touched by something in front of its body part, but no neuronal activity, of course, only muscular activity is simulated, just to check the biomechanics of movement, how it works, how much time it takes to perform this reversal, and is it possible? So everything is okay about this. In general, it works. And further work is, which I plan to do, is about details tuning of the parameters, making the movement more realistic, and so on.
No worries, Porg. Thanks for joining. We'll have more extensive chats next time.
And well, also about the paper, I wrote to the editors and received a message and answer today that the paper was sent for 3 reviewers, but only one sent his review back to editors, and others, by some reasons, decided not to review. I don't know why. Maybe they don't feel they are enough. They're specialists enough in this or something. I don't know these reasons. But now we need to wait for quite a short time. The editor needs either to make his own choice depending on his opinion and one review, or maybe he will decide to send it to more reviewers. But in any case, those guys wrote me that they will update the information and I will know what happens. So we can continue, and after 2 or 3 minutes I will run the video of this crawling and reversal.
Okay. While you're waiting, let me also update a little bit on cybernetics. So a couple things. One, there's been a new Gitter channel started. It's for cybernetic. It is where you'd expect it to be under gitter.im/openworm/cybernetic. And the conversation that we've been having over there, you may remember there was a lot of this talk about Docker at the end of last year, and we sort of focused that on a specific use case for some of the cybernetic work, which was basically, as Andre is doing his simulations, he basically gets to do up the maximum of 2 at a time, and they take, on the order of tens of hours to complete when he's running cybernetic. And so we thought, hey, if we could do a Docker instance that has cybernetic, which the current OpenWorm instance has in it, and we did the Docker thing, which is to make it so that it's essentially stateless, but when it starts up, you give that container configuration parameters, then we might be able to extend his ability to do just 2 simulations a day to some arbitrary larger number of simulations a day, leveraging Amazon Cloud. So we have been working with him and another contributor named Tao, who was the guy who got the Docker thing to work and got cybernetic working on it, so that you don't have to install OpenCL to get cybernetic to work, and you just have to install this sort of Docker container, which is a huge step forward because the whole OpenCL thing is a big problem. So in the last few weeks, we've been getting together here, getting closer and closer to having this thing run, and hopefully give Andre the ability to run a lot more experiments. So that's just one of the things I think that we can do now that we're getting a little bit more focused on deployment of the code base, and I would hope that we can build on top of that as well, to not just run cybernetic, but to run this whole loop that also includes simulating the neurons and whatnot. But this is kind of the first major thing that we know will speed up a very specific thing, which is basically Andre's continual updates to the body model. So okay, good. Looks like I filled enough time. So what are we looking at, Andre?
Well, now we can see that the worm is crawling forward, and it will continue for about maybe 30 or even 50 seconds, and then the reversal will follow. So we can just keep an eye on this, and when it will be necessary to look more attentively, I will just inform you.
So everybody hopefully understands that. So far the worm has only been crawling in one direction, crawling forward. But we know that the worm will sometimes get I don't know, like somebody will brush its nose or something, and then it'll immediately start crawling backwards. So now the model also crawls backwards, basically. Because it moves so slowly, it's kind of hard to see, but it's a kind of an important milestone just from the physics to confirm that it's physically possible for this thing to both move forward and move backwards, given all of the frictional forces and all that kind of stuff. Yes, good. Yes, show that, Andre. Yeah. So everybody can see the Andre screen. Basically, this shows an example of exactly that. Worm crawling forward under auger, then getting tapped on the nose, and then crawling backwards, although he takes a slightly different path. But that's the reversal. So basically, we've just been trying to get that confirmed. And the other thing maybe to say, Andre, is just about the new paper. So remember, there's two papers about cybernetic. One is about the engine, and the other one is really applying the work with the worm. So a lot of these computational experiments now are really aiming at trying to get this second paper pulled together. We've been using past work by Netta Cohen as a model in terms of what tests that they ran to put in their paper, like what results they wanted to show. And we're trying to basically replicate those same results, but using cybernetic. And so this is a critical piece for that, both forward and the backward, and like the crawling versus swimming is the other piece that we're trying to get, because we want one model that kind of capable of doing both. So, yeah, Andre, do you want to say any more?
Not yet.
Okay.
Maybe after 20 seconds.
Okay. So maybe we should move on, and then we can come back when it's actually doing its moving in the other opposite direction thing. Yeah? Okay. Great. So guys, let's keep going. So let's see. Looking around the room here. So Giovanni, have any updates for us?
Yeah, I've been doing more coding than in the last couple of months. Lately, kind of mainly contributing towards some improvements in Geppetto. Also, there's some other interesting stuff that's going on in Geppetto related to cybernetic. I know that Matteo is working with Sergey to pull cybernetic record. We can already play cybernetic recordings in Geppetto as we have used for the worm sim. But now there's some changes that are happening in Geppetto. It's like a big refactoring to improve performance, and this is causing some changes in terms of SPH specific stuff. And I know that Sergey is working on that stuff for Matteo, so just at the interface between cybernetic and Geppetto. And as far as I'm concerned, I've been working mainly on a huge refactoring together with Matteo and Adrian on Geppetto stuff that, I mean, OpenWorm will reuse. So everything, pretty much all the simulations that we have, the muscle cell, the C302 stuff, and even playing recordings, everything will be faster because of this refactoring we are doing. So it's just a huge undertaking. I don't want to go into kind of too much technical details, but it's hard to show anything because we're kind of in the middle of it. But hopefully, definitely, the next OpenWorm meeting we're gonna have something to show. So yeah, so a lot of coding. Not a lot to show for it other than the GitHub activity. And that's it. Kind of in the trenches right now, but hopefully by the end, by the next meeting, we're kind of emerged with something to show, which is pretty much going to look the same but faster. But yeah, there's a huge refactoring in the back end as well. It's basically introducing this type system to Geppetto. At the moment, like for example, like you have 302 let's say C. elegans neurons in C302. At the moment, we have like a duplication of all these neurons, even if they're all the same type. While after this refactoring, there's only going to be one actual. It's going to be 110 place, 302 placeholder. They're pointing to the same type, so avoiding this insane duplication that we had before, and that's going to speed things up, in particular for big networks. But yeah,
Awesome.
Pretty much it.
That's great. When do you think those refactorings are going to be kind of available for folks? Is there like
No,
an
it's
estimate?
already. I mean, if anybody wants to pull it down, and it's work in progress, but it's already usable in the instance type branch of Geppetto, so you can just get all the repository under instance type. But it will be finished in the next 2 weeks. It will be done. So definitely, that's why I was saying next time we meet, probably gonna be more to talk about, and probably some comparables in terms of performance from what we had before, what we have now.
Cool.
Yeah. So it's gonna also be nice to see how cybernetic recordings come into play with the new format. We'll be able to play bigger scenes with less performance issues.
That'd be great. That'd be awesome. I'd love to see that.
Yeah.
Okay, excellent. And
I have paused the simulation, and
yes,
it is precisely the moment when the reversal starts.
okay.
So,
Since it's slow, I think we can
yes,
probably.
unfortunately, this is already a recording, not a real-time simulation, but
Yes.
still very slow.
Okay. Well, let's get Michael's update here as we're watching it move.
Okay. We'll be really,
Oh wait, sorry. Yep. Giovanni.
sorry to cut in, but just what I was saying. Like, it would be really nice as we have done for the worms, and to get these recordings from Andre and Sergey and transform them into Geppetto recordings, and then we can make them as fast as we want.
That's true.
Pretty cool.
Yes, closing that loop would be awesome. Having like automating that pipeline that we did once for WormSim, I think also. But yeah.
It'll be even easier now, because I know that Sergey is working on a Geppetto wrapper for cybernetic, so we're fairly close to that.
Awesome.
And it's gonna split out the recording, and then the recording will play. And once the simulation is finished, you can just play the recording really fast.
Cool. So I think you guys can start to see now that the nose has moved from.
Oh, there, it's moved. It's moved.
Yeah. You guys see that? So how it's starting to move backwards. Yeah.
So I hope I will be able to record a video and upload it to YouTube separately, and this will be significantly increased in velocity, maybe 10 times faster than now, and everything will be much more obvious and easy to see.
Excellent. Looking good. All right, Michael, do you want to give your update?
Sure. So, movement analysis. We have a meeting this Friday, meeting number 14, I guess, of our standing monthly meetings. So, feel free to attend if you're interested. Well, a few things have happened, quite a few things since I last gave you an update. A big one is we got a name for our tool, the OpenWorm Analysis Toolbox is what we're calling it. It used to be called Movement Analysis, but we're going to go with a more general name that also has some connection to the tool we were porting, which was the Worm Analysis Toolbox, which was from the Schaefer Lab. So we're calling ours the Open Worm Analysis Toolbox. And it's same functionality, but new name. So another big development is this worm tracker specification. in the Tracker Commons repository. So this is an initiative of Rex Care and Andre Brown. They wanted basically a format that lets worm trackers around the world, doesn't matter how they're implemented, but they want these trackers to be able to communicate with each other, or at least generate a format that can then be read by other programs downstream to do analysis. And so agreeing on a common way to specify the information about the worm as it's moving around in the tracker seemed like a good idea. So they developed a specification, and then Rex developed a parser for this specification in Julia, and then I did one in Python. So next step there is to make that specification something that we're using within the OpenWorm analysis toolbox, and that's basically something that I'll be doing right as soon as we finish our refactoring, which is ongoing still. Jim is working very hard to make that refactoring work finish. To finish that work, he's close, I think, and I guess we'll get a bigger update on that this Friday. Apart from that, Aiden Rock is still working on behavioral syntax repository there. I have a link to that in the agenda as well. And so that's another way of breaking down the worm's movement. And he's been working on porting this MATLAB analysis tool that Andre Brown came up with into Python as well. And then we'll move it into the OpenWorm analysis toolbox. It'll be another tool in our toolbox. So that's what's happening with movement analysis.
Awesome, very good. So the latest on that, as far as like just running the tests, like if somebody wanted to go in and run it, where is the place to go now in terms of like on GitHub?
I think the beautiful thing about GitHub is I think that it will still persist the old name, like it won't give you a broken link. But
okay.
Instead of GitHub/OpenWorm/movement_analysis, now it is GitHub/OpenWorm/OpenWorm analysis toolbox. So there's a link there in the agenda for that if somebody wants to go there.
Okay. Also on behavioral syntax stuff, just to kind of loop in the next month or two, we will also be looking to get Andre in to do a journal club to talk about the latest stuff in that forum. And so that might also be a good milestone when you talk with that team on Friday to let folks know that probably within February we're looking at we'll have talk about it. So however the tools can be brought up to speed by the time that happens, it'll be a very real-time feedback probably from the community as to where to go, what to do, how to use it, that kind of thing.
That's perfect. I'll remind Andre of that if he's attending, and I'll mention that to Aiden. Hopefully that will. I mean, I'm also working with him a little bit on that. So yeah, the two of us should get going on that for sure.
Yeah. I don't remember exactly how it went, but Andre may even be presenting. So.
Yeah, I imagine he would be. Yeah.
Cool. All right. Very good. Excellent. Alrighty, so I was hoping maybe to give some time here for Matteo to join. I know that he's in another meeting right now, but I think he's not going to be able to join this time. So I think we may break a little early today. Just kind of getting through that update. It looks like a lot of folks had things packed up here at the beginning of the year. But we'll be looking to do this meeting again. In a few weeks going forward. Also, I think in terms of just getting ourselves coordinated around integration, I've been having some thoughts about how to kind of take the activities that we've been doing and possibly split them out a little bit more so we can think about science on the one hand and technology on the other hand and community as well. So let's stay tuned for more on that. All right, that was loud. Stay tuned for more on that over the next few weeks, just in your inboxes, and possibly in the next meeting we might take a little bit of a different tack on how we talk about these different pieces and components, depending on if folks are see the see a benefit in possibly reorganizing the way that we have these conversations. It's a new year, so I think it's time again to think back to the goals that we had originally and see if there's a way to possibly re-up our structure to get those things done. So, but beyond that, cheers to 2016, everybody. Thank you for spending time with us, and we will see you guys at the next meeting.
Thanks, dude.
Okay.
Yes.
All right.
See you. Bye.
Thank you.
Cheers. Bye-bye.
Good gifts.